Hi everyone, welcome to this Pi and AI session. In this Pi and AI session, we are going to talk about PyTorch Lightning Flash. Hope my audio is clear. If you have any question, then feel free to ask in the chat section or probably raise your hands. Okay, so in the last Pi and AI session, we talked about PyTorch Lightning, how you can move your code from plain PyTorch to PyTorch Lightning, how you can scale your model and reduce the boilerplates and all. So in this meetup, we will talk about PyTorch Lightning Flash, which is a high-level deep learning task-based framework for and it will help you to build quick models quickly and quickly prototype state-of-the-art models for you. So I will first give you a brief introduction to what we talked about in the last Pi and I meetup. Basically, I will walk you through the PyTorch Lightning and the structure of PyTorch Lightning. Then I will talk about what is Flash and how the APIs of Flash works. So after that, I will show you a Kaggle plant pathology competition, and I will try to solve it with Flash. So let's get started. Okay, recap, model training overview. So for training any machine learning model, first you load your model, then you prepare your data set. You do post-processing, pre-processing, all those things during the data preparation. Then you define a loss function. It can be cross entropy, binary cross entropy, or anything according to your task, the problem you are solving. And then comes the optimizer, which will basically optimize the weights of your neural network model. Then you write a training step. Training step will take your model, your data, and it will pass your data through the model. So the model produces the prediction from your data, and you calculate loss on the predicted value from the ground truth. Basically, you calculate how much deviation is there from your predicted values and the ground truth values. And all these are connected together to train your neural network model, and back propagation is done to make your weights shift towards the shift towards a lower loss of the whole criterion. So basic components of Lightning. All these model loading, loss definition, Atom, SGT, any kind of optimizer definition, and the training step are contained inside Lightning module, which is provided by PyTorch Lightning. And model define forward function. So basically you can provide your data inside the model, and it will return the logics from your model. Then you configure optimizer. You can define Atom, SGT, or RMS prop and just return the instance of your optimizer. Then you write the training step. You can also write validation step if you have a validation data set. So you should definitely write it. And then you have data module, which basically consists of validation data loader and training data loader. So let's see how those basic components of Lightning are used to train a model. So first you define an init function whose parent class is Lightning module. So inside the init, you define your model loss function and all the objects. You create a forward function, which will pass your data through the model and produce the logics. Then you define configure optimizer method. It will basically returns the optimizer instance. So it can be Atom, SGT, or RMS prop, whatever you want to use here. Then you define a training step. You can also define a validation step, but for simplicity, I have removed that. So in the training step, you have batch and batch index. Batch is basically the current batch of your data in the epoch. So here batch means both input and the target value. And batch index is, suppose if your 1,000 your data, your single epoch contains 1,000 batch of images or any kind of data. So it is 0 to 999. In the training step, you calculate loss and return the loss value. So how do you train your lightning model? You create a trainer object from tl.trainer class. Then you do trainer.fit. You put your model and data module there. And as soon as you do trainer.fit, Lightning will automatically start the training for you. So Lightning also provide a lot of cool stuff like callbacks for weight and biases, ML flow integration, TensorBoard integration, automatically convert your model to 16-bit precision, and a lot of things is provided by trainer.fit. So you should, if you want, you can check out my last video. It is in my YouTube channel. And for this meetup, those things are not required. So let's go ahead. So there is one question. And it's the last event. How can I access its content? The content are available on my YouTube channel and my GitHub repo. So the code is available on my GitHub repo. So this meetup will also be recorded and will be available on my YouTube channel. So you can watch it later as well. I will put the link and my GitHub link and my YouTube link in the end of the meeting. So PyTorch Lightning Flash. Flash is a framework of tasks for fast prototyping, baselining, fine-tuning, and solving business and scientific problems with deep learning. And it is focused on prediction, fine-tuning, and task-based training. What is task-based training exactly? So in deep learning, you have different kind of tasks like image classification, image segmentation, object detection, style transfer, text classification, question answering, even speech recognition, video classification. These are the tasks that are already available in Flash. Let's talk about image classification. So first of all, I have imported all the classes and methods that I am going to use: image classification data, image classifier, and semantic segmentation. Image classification data. Let's talk about. So the data set is not always in a same kind of manner. Sometimes it is arranged in folders. Sometimes it is arranged in a CSV or data frame. Sometimes it is available as a list. So in this example, I will show you how you can load your dataset from folder. So what this dataset structure is, let's see. If I do ls here, so you can see inside my, so I am using tiny ImageNet dataset, which is a dataset containing 200 different classes. It is a smaller version of ImageNet dataset, which has a total of 1,000 classes. So inside the train folder, you have all the 200 folder for all the 200 classes. So this is class 1 folder. Inside this, you have image for all these images. So inside this, you can see there are a lot of images. So all the images belongs to this class N01. It is and similarly you have for validation dataset. So what I do is I just call image classification data dot from folder. I provide my training dataset path. So let's see the function signature. So it has train folder, val folder. Even if you don't have validation folder, you can split the training dataset for validation dataset. So you can specify val split is equal to 0.1. It will distribute 90% into training dataset and 10% into validation dataset. But I already have a validation dataset, so I have entered it. Then I run this and you get data visualization out of the box. You don't have to write anything for visualizing data. No, not any matplotlib code or any data visualization code. So all you have to do is bm.show train batch, and it will visualize your data set. So these are the class index, and these are the images for those particular classes. What else? What does this image classification data offers? Apart from folder, image classification data has from data frame, from CSV, from files, from JSON, from NumPy, and from tensor signatures. So you can load your data set from these kind of data set structure. So you can load from just JSON or NumPy as well. So feel free to check it out. Now you have your data set, custom data set, and you want to train an image classifier for it. For any kind of image class model in Flash, it has basically two components: backbone and head. So in image classification, this is an example of AlexNet. Here you can see this is architecture for training AlexNet on a 1000 number of classes, that is ImageNet dataset. So you see the path from here to just before the softmax layer, these are called backbone. And the softmax layer is basically 100 dense neural network, which is called as head. So the head is basically responsible for generating the prediction. So right here, there are multiple different kind of backbones available in Flash. So as a backbone, you can replace this particular architecture just before 1000 with any kind of backbone, whether it is ResNet, Vision Transformers, or exception efficient net, any kind of backbone you can replace it with, and just put a linear layer of number of classes in the head. So let's see what are the backbones available. So total of 619 backbones are available in Flash right now. Mostly thanks to Tim, PyTorch image model, which provide a lot of pre-trained CNN models, and PyTorch Lightning bolts as well. So let's see last 10 available backbones: VIT, Vision Transformers, ResNet, and ExceptionNet. So you can select any of this backbone to build an image classifier. So I'm using ResNet 18, and I have specified number of classes, which is for my data set is 200. So when I call this, you can set pre-trained, whether you want to load the pre-trained weight from ImageNet or not, and then just run this. After you run this, let's see what this contains. Let's see backbone. So if we do backbone, you can see ResNet here. So this is the ResNet 18 model, which has been loaded. Now if we do model.head, it is a linear layer, basically dense layer or linear layer, fully connected neurons. And the output size is 200. That is number of our classes. So that's how image classification model is created in Flash. Okay. Let's proceed to semantic segmentation. So in semantic segmentation, the head and backbone are not this straightforward. So generally there is a encoder and decoder kind of architecture. So for UNet, there is one encoder architecture, then decoder architecture. So here I see available, if I do available backbones. So these are the available backbones for semantic segmentation: DenseNet, EfficientNet, and MobileNet. A lot of backbones are here. So let's put some backbone right here. Let me copy it below. Okay. Let me select VCG 13 or 11 and head. So let's see what are the available heads. Let's select FP in here and number of classes. So VCC 11 is being downloaded. It is 507 MB. Let me load something that I have already downloaded. Do they provide ResNet? Yes. So let's see what is inside this model. So you see, in my head, I have FVN block. Just to head. So I have this FVN block, and it is basically the decoder part. So it is responsible for generating my image. And if I do model.backbone, it will give me the encoder, ResNet encoder part. So all of these things are automatically taken care of for you by Lightning Flash, so that you don't have to worry about creating an encoder, decoder, then attaching them. So you just instantiate your model, instantiate your data set, and just then run flash.trainer and then fine tune the model. During fine tune, Flash provides certain multiple strategies. So if you see here, in strategy, you should, it is a string, no freeze, 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 unfreeze, and unfreeze milestone. If you set it to freeze, it will freeze the backbone, basically set the backbone to non-trainable. So that when you fit the model, backbone will not be trained and only the head layer will be trained. Okay. And when you do unfreeze, then the whole model will be trained from when you do model.fit or trainer.finetune, trainer.fit. When you do unfreeze, it will freeze for some time, and then it will unfreeze the whole architecture so that you do not have to interrupt and then do unfreeze by your own. So multiple strategies are provided for you. I will not run this right now because I am on my CPU, but Lightning has this fast dev run, which will basically take a single batch and train the model out of it. So it just checks if everything in the code is correct or not. So it seems everything is correct. And these are some warnings, I think some internal warning. Let's not worry about it. And then for predicting for generating prediction from your model, all you have to do is, if you have an image, I have this image here, and just input the path of the image, and it will create a prediction for you. So it has created a prediction for me. So this was about what are the things provided by PyTorch Lightning Flash. Now let's go through this Kaggle competition. Okay. So we will be talking about plant pathology Kaggle challenge. Let me see. Okay, if it is, my instance is still running. So my instance was terminated. No issues. So first I've installed all the Lightning packages and all the required packages for Lightning. I have imported, okay. Let's go through the code which was running successfully. Okay, so in the data dir, so this is a this is a path where all my training data set is stored. Kaggle input planet, and this is the competition name. Usually, Kaggle data sets are stored in this way only, Kaggle/Kaggle/input, then the competition name. So I have train.csv. In train.csv, you can see here, there are three columns here: image, label org, and labels. This label org is created by me, and the labels org was already present here. So I have image path here, and for each image path, I have the label for that image. So basically, it is a. Let me show you what is the data set. Okay, so it is a data set of different kind of. Can you help detect farmers' apple diseases? So it is an image data set where the plants, or you can say leaf or the apples, have some disease, and the labels contains what is the kind of disease. So there are total of 6 diseases in this data set. One is not 6, it is 5. One is healthy, that is positive class. So scab, rust, powdery, mildew, then frog eye leaf spot, and complex. So these are the different diseases present in the plants, which we have to train a model to classify for. So after loading my data set, I have visualized this plot. I have not, so basically some of the code is borrowed from notebook of Jirka, who is a senior researcher at PyTorch Lightning. Then I set batch size and image size. I did the training transforms and validation transforms are defined here. Then I will convert my data into one hot encoding. So the labels has to be converted into one hot encoding. So I have total of 6 labels. So I have created 6 columns for each of the label: complex and frog eye, healthy, rust, scab. I have converted the data into one hot encoding using multi-level binarizer, which is a class from scikit-learn. So after I convert the data into this one hot encoding, I merge this one hot encoding data frame to the original one, and thus this is the resultant data frame. Now I will split the data set into 90 and 10% for training and validation data. And then I create a plant data set object. So torch has torch.data set, which you should use, which you can use to create a data set object, and which can be converted into a data loader. So if you see, I have imported from torch.util.data, import data loader and data set. So this data set you have to use to create an object, and then that object can be converted into a data loader for training their model. So you have to define len, which is basically a Python dunder operation, and it will return length of all the total data images available in my data set. Then I will create get item. This get item will return input image and the target labels. Then I will create a lightning data module. It will basically return train data loader and val data loader. The train data loader is nothing. It will convert my train data set, which I created earlier, into a data loader object. So you can go through it. The best way to read about data loader and dataset is in PyTorch tutorial. So they have created a very good example for how to create your custom data loader and custom dataset. So I have shuffled the training data loader and not the validation data loader. After I create the data module, I create my image classifier. So like I showed you, you just have to enter number of classes, the backbone you are using. Right now I am using ResNet 50. And this is a multi-class classification, multi-level classification data set. So one leaf can have multiple diseases. So that's why I have set multi-level is equal to true. So when you have multi-level data set, you should use F1 accuracy instead of generally using accuracy. That gives you a better representation of your model performance. So then I create a trainer. So flash.trainer, and I have entered my total number of epochs. PyTorch Lightning Trainer has several flags which you can set. So I have, instead of manually picking a learning rate, I have set auto find. So it will try to find an appropriate learning rate for you. I have one video tutorial on this, on how you can find the learning rate for your model. So it was in TensorFlow. You can go to my YouTube channel and check that out. So I have said benchmark is equal to true. Basically, torch has CUDNN, torch or CUDNN dot benchmark is equal to true. So when you set benchmark true, it will go and set that to true. The benefit of doing this is it will try to auto tune some of your algorithm selection based on CUDNN. So, and by default it is false. So you should always set this to true. One more thing is when you create any kind of data loader, by default in PyTorch, number of workers are set to 0. So if suppose if you have multi-core laptop or multi-core compute available, so you should definitely increase this number of workers. So basically, what you can do is, for simplicity, you can just import mproc, which is from multiprocessing library, which is Python's built-in library. And you can count your CPU and just pass the number of cores available to self.num workers. And you should always set, you should most of the time set pin memory is equal to true. What pin memory does is, so you have to transfer your data from CPU to GPU, and that takes some time. So pin memory decreases that time. So by default, it is also false. So you can set it as to true. Now I have created a trainer. I have to just do trainer.findTune. I pass my model here, my data model, and set the strategy, which is freeze and freeze. So it will first freeze the model and train, and then it will unfreeze the model. And now I think the training logs are deleted from here. Okay. So after you have trained your model, you can calculate the results. So this is the code for results. So I have used torch.nograd. So whenever you are doing any kind of prediction, you should definitely use torch.nograd, so that the gradient are set to zero or none. And so I have created a submission data loader for my submission data, CSV data. I load my images and calculate the prediction. Then since I have multi-level data set, I create do prediction.sigmoid, and then greater than 0.5. If the sigmoid value is greater than 0.5, then it will be true, otherwise false. So I iterate through the predictions and convert the true and false value back to labels, string labels. So and then I return all the results which are appended into this list. And then I just this was my submission data frame, and then I just replaced these labels by the label that I calculated from my model. So that's it. So you didn't have to do much for this, just that you create a data loader and uh, automatically a model is created for you based on the choice of your backbone. You don't have to apply any, you don't have to create F1 accuracy tracker metric, or you do not have to define anything. One more thing is I have created this data loader and data set here manually. You do not have to do that. So PyTorch Lightning Flash already have image classification data dot from CSV and from data frame. So you can directly use that. So you don't have to even write this line of code. It is done automatically for you. So definitely check it out. If you want to learn more about Lightning Flash, go to the Lightning Flash documentation. And since I told you this is a task-based API, in the sidebar, you will see image and video, audio, tabular, text, point cloud, graph, and all. You expand image here and see image classification and different, you have examples here which you can follow to train your model. You have example for loading your data set from folder, from file, from data sets. You have an example for custom trade transformations as well. So if you want to add custom transformations, that you can as well. Flash also has serving. So after you train your image classification model, you can serve it easily. You can do model.serve and an API will be created for you. You do not have to write any fast API code or Flask code by yourself. Just train your model and call model.serve. Then multi-image classification. So this is an example of loading from CSV. So in the Kaggle challenge I showed you, I load the dataset manually, and you do not have to do that. You just specify your training file, metadata.csv, your validation CSV file, metadata.csv, and these are basically the labels. By label, I mean in my example. So in my example, you see complex, iFrog, healthy, Rust, scab, all these are my labels. So I pass a list of labels here. So these labels are passed, and you can provide your image size, and this will be automatically created for you. You do not have to do anything. So it provides out of the box integration with other libraries like weights and biases as well for training a model. So feel free to check it out. If anyone has any question, they can. Okay, there is one question. How do you log metrics? Flash has a torch metric, which is created by Lightning team. And if you are working with Flash, most of the time you do not have to write metrics on your own. Okay, your question is how do you log metric? So for logging, Flash Lightning provides, there are multiple ways to log. One is you can go and you can log to CSV. So there is a callback called CSV logger. Then you can log to TensorBoard or MLflow or even weights and biases. So let me show you the exact method. PyTorch Lightning. So callbacks API. You have log API, sorry. Yeah. So you can log your metrics inside CSVs, MLflow, TensorBoard, or weights and biases. Let me show you some example. CSV log. Yep. So to enable CSV logger, all you have to do is from PyTorch Lightning.loggers, import CSV logger and put the CSV logger object inside logger is equal to logger. And this was for CSV logger. If you have weights and biases, you will have to install weights and biases and create an account on weights and biases for that. So from PyTorch Lightning.logger, import vanvlogger. You pass the project name and just pass the vanvlogger inside trainer, and it will automatically do the job for you. That's pretty easy. Okay, so I think there is no question. Are there any viz for GradCam? PyTorch Lightning doesn't have any callback for GradCam, I guess. But let me check. No, I don't think there is any visualization callback for GradCam, but you can use Captum for that. So Captum is a PyTorch library that can be integrated into PyTorch Lightning, I guess. So feel free to check out. Maybe Captum already has some callback for it. Okay, no more questions. I think we have 5 more minutes. On model serve, does it create an API in GradAI? No, it will create an API on your local laptop. You can deploy it to your own server, not on GradAI. But you can use GradAI. Flash 0. Flash 0 basically allows you to build models from command line. So you do not have to write any code per se in Python. So this is Flash 0. So suppose if you have to train image classification model, you can do it from your command line, your terminal. Flash image classification, then model backbone, result 15, number of epochs. All of these can be done automatically. You can do from folder. You can specify the training folder and just enter. I don't think it does any hyperparameter search as of now. Cool. So thank you everyone for joining. I will put the links to the recorded YouTube video and the slides. I have. Let me allow the slide for public. Copy link. And this is my GitHub where you can find the link to YouTube video and the code and Kaggle code that I have used. So you can, so for the last Lightning video are available in this one, 2021 627 PyTorch Lightning. And slide, you can click here to get the slides, and the YouTube video is available in my YouTube channel. So You can go to my website, aniketmaurya.com. You can pretty much find anything, everything right there. Okay. And as a last note, after this meetup, you will receive an email and feedback form from Pi and AI. If you fill that form, then you will get 50% off on Coursera, any Coursera course. So fill the feedback form and get 50% off on Coursera. Thank you everyone for joining. Have a nice day or end of the day, wherever you are. Thank you, Ramesh, for sharing my Twitter.